Hello and a warm welcome to the podcast series of Circuit Digest. Normally, the term rocket science is often used to refer to things that are very difficult to achieve. But the person with us here today believes that by leveraging the advancements in recent technologies, it is possible to design and build rockets for outer space. His company, Agnikul Cosmos, is building India's first private small satellite rocket and it is expected to make its first launch by 2022. Curious to know more about their work and the challenges they face in the early aerospace Indian market, we approached Moin, who was the co founder and COO of Agnikul. So let's hear from him on the call. So, again, thank you, Moin. Thank you so much for joining us on a Sunday.
Thank you for having me here.
So, Moin, the first question for you would be like, Agnikul aims to build private low-cost rockets for small payloads, right? So why did you start this journey and what is the need to build a separate rocket for small payloads?
Uh, to start with, I think one of the primary factors was there was a paradigm shifts in the industry that was happening, right? To say like in the 90s, we had the IT industry growing. And then in the 200s, you had the, 2000s, you had the biotechnology, robotics taking up shape in 2010 or something. And then came the era of the space industry where before it was only being controlled by space agencies of the countries. But we saw a change in the Western Hemisphere where SpaceX was trying to uh, democratize space, privatization of space started to happen. This was one of the primary factors because like I've been an aerospace engineer myself and I've also done my master's in the same field. So what happens is like we knew an opportunity for engineers from India had only two options to get into aerospace. Either it was ISRO or it was HAL, correct? Apart from this, we didn't have any options. So this gave us a kind of like an interest where everyone in the space industry needs to be having an opportunity. And this is how it all started from. To go into specifics about building a launch vehicle itself, right? We saw that the satellites were shrinking. Okay, there was a demand for a rocket that would accommodate the shrinkages of satellites. And beforehand, there used to be a kind of a big satellite that was used to be like positioned at a geostationary orbit. And then we saw the market also going towards about constellation of satellites where they didn't need to risk all the eggs in one basket. And instead they divided the big satellite into small parts of it and they made the satellites talk among themselves. So we saw that the big satellites are also being converted into small satellites and the satellite size, the CubeSats, the nanosats, they themselves were shrinking in size. So this gave an opportunity for us to think, to meet this demand, we needed a rocket that could accommodate this particular payloads, this particular satellite sizes. That is where we identified the need for a rocket such as this.
Okay, so that's interesting. So your first rocket is called Agnibaan, right?
Yeah.
So your ultimate aim is to reduce the cost of building these rockets. So what are the major ways in which you have reduced the cost of your vehicle, Mohan?
Sure. So let me start with what Agnibaan means. Agnibaan in Sanskrit actually means a rocket, right? And to reduce the size of the vehicle, we incorporated multiple technologies that are available in today's world. For example, I could start with additive manufacturing, right? That plays a very key role for us. Likewise, we have other technologies even in the conventional side of manufacturing about how we could be doing, such as rapid prototyping we could do. Then we also have other industries as a platform for the electronics has been now come off the shelf. So there are multiple ways that where we are trying to reduce the cost of a vehicle itself. Instead of using like how to say expensive IMUs, we've also had another option about how we have to like thinking about a navigation system, right? So the total reduction of the vehicle itself has been because of two reasons. One, India has been a spacefaring nation for nearly 50 years, and there are a lot of like vendors who understand aerospace standards and have been manufacturing into them. And there are a lot of vendors who actually do this for the rest of the world as well. And primarily, they are focusing and working with ISRO. So we've already had that ecosystem. That ecosystem gives an edge in saving all our instead of importing all the other things indigenously inside India, we could also afford to get this. That's the first reason. The price reduces. Then we also have the other technologies where we're using them as a platform to reduce our prices.
Okay. So Moin, one question that I did come across with your answers that you told you're getting electronics off the shelf, right? So is it are there Indian vendors here who provide off the shelf electronic components for aerospace? Are there many vendors here in India? And how does it reduce the cost? Like getting electronics off the shelf, does it really reduce your overall cost?
Yes, Ashwin, it does not. But what happens is it is something that would have already been manufactured and would have proven its credible and heritage, right? The electronic components already being flown in space. There are certain types of vendors who have worked with ISRO before or have been supplying for other aerospace systems. What we are trying to do here is design our own, correct? And we are asking them to manufacture those components.
Okay, okay.
So the design cost is completely being borne by us. This reduces the cost, and the off-the-shelf is just an integration about what they've actually done and what we need. So the cost drastically reduces.
Okay, okay. So moving on to the third question. So the major challenge for you would be to build the rocket engine. So tell us about your semi-cryogenic liquid propulsion engine, Agnilet, right? Agnilet, am I pronouncing it right? So how does it differ from the other small rocket engines out there?
So we have two engines here. One we call it as Agnite and one we call it as Agnilet, right?
Okay.
And both of them are semi-cryogenic. Just as you have said, it is a liquid propulsion. It's obviously right. So what differs is comparatively to the rest of the world, we are able to manufacture these engines through additive manufacturing in a single piece. Correct, which means there are thousands of parts. If we had to do this conventionally manufacturing, there'll be thousands of parts that need to be manufactured separately, and they would have to be fused through other forms of weldings to make it into one piece. But here we have an opportunity to create an entire 3D printing engine into one single shot. We also have other countries, we also have other companies that are focusing on 3D printing, but they are building at least 2 or 3 pieces and then they're trying to fuse it to make it into one block. But our engine is different in such a way that the entire engine, comprising of all components, is printed into one single piece. That is how we are completely different from the rest of the world. 800.
Yeah, so in one of your interviews while you were speaking, you said that you're trying to leverage the 21st century technology to build a rocket more efficiently and more cheaper, right? So apart from 3D printing, what are the other recent technological advancements that is helping you to build a rocket in a more cheaper?
Engine of Agnite, right? So we have a kind of an engine which will be powered by pumps. We call it as turbo pumps being powered, which uses batteries to drive the pump itself. Okay. So we are using electric vehicles advancements made of the battery sector, correct?
Okay, okay.
This particular technology is also used to develop our engines, our batteries and our turbo pumps.
Okay. So what are the future rockets of Agnikul will be like? Are you planning to use 3D printing technology for all the future rockets, or do you have a production model in mind? Will that also be 3D printed?
Yes, we do have we go with the concept of modular design, right? Wherein we have the capacity to print the same engines. Maybe the same first stage could be mounted again as boosters, right? And we could actually propel towards having or taking more weight. This gives us an opportunity to just reprint the entire first stage again and try to utilize it as a new vehicle. And in future, we also are planning to have reusability, which is also going to be a kind of a primary aspect for us. And obviously, we also have plans of exploring beyond the space, going to Moon and other missions as well.
Okay, okay. So Moin, after a launch, how long would it take for you to prepare your next rocket, let's say from the production process?
We are thinking to have a modular design complement us in such a way that we would be able to launch in 2 weeks. So the entire additive manufacturing time taken to print one engine is less than 72 hours for us. So we are trying to automate the entire production process of ours in such a way that we will be able to launch a vehicle every 2 weeks.
Oh, that's really fast. So, Moin, apart from engines, what are the other areas that require a lot of development time, and what technical difficulties do you often face with your work?
See, research and development has its own kind of charm, right? It has its own difficulties, but the newer technologies are helping us to solve that developmental cost as well as time, right? For example, I can tell you, if we had to develop the same engine for conventional manufacturing, I think just the manufacturing time itself would take around 3 months for us. So this reduces the time, and the opportunity for additive manufacturing has given us in such a way that we've reduced developmental time as much as we could, and gives us an opportunity to iterate with n number of iterations that we need. It is not fixed, because in conventional manufacturing, we would be like spending tons of money to just get one product.
Okay.
But here we have an opportunity to print or like scrap it and then reprint it again if the iteration is not successful for us. Likewise, in the electronic side, what we have an opportunity is like the developmental cost could also be done on similar platforms. Likewise, we might not build a complete product initially, but we would test out the efficiency of it through like smaller kits that are coming in electronics, and then we try to validate them.
Okay. So apart from engine, where do you spend most of your time, Moin? So what are the other areas where you have to spend time?
So turbo pump is one of the technological advancement that has been made in the rocket science itself, right? Electronic turbofan pump. So this is somewhere our time is completely dedicated to. So we are using a motor that will drive the pump to push the fuel inside the engine, right? So generally, it is that's the advantage of having liquid engines. And this is also an advantage in such a way because for future missions, once you've mastered the liquid engines, you could also use them for longer burn times as well. So this is exactly because it has multiple components for it. It has motor, it has drive, it has multiple things that need to align the battery, right? Everything needs to be tested, needs to have reliability on itself. And then all have to be integrated to make the vehicle fly. So this is currently where our time has been focused on.
So Moin, so Agnikul is a company that's one of its kind, right? Like it's not like any other startups out there. So you're kind of leading the way. You're kind of showing people how you can start up into this aerospace industry. So being among the few players in this private space industry, what kind of challenges do you face? Especially since you're from India, so what kind of challenges you face here?
So first of all, starting in an aerospace industry is quite fascinating, right? Because it is something that you're trying to bring together. But obviously, the challenges that we faced were like the investor market was not accommodating the space industry initially, right? Or it was not in the thesis. And going down the line, people have started to explore the space industry, its opportunities and its advantages, and have understood that space could be a platform for multiple other industries. Right? So, for example, there is an entertainment industry could also use space as a platform. The medical, pharmaceutical could also use space as a platform. So people have started exploring these options. So this is giving us an advantage over the others. Likewise, the other difficulties I would say is like have all been resolved right now. Thankfully for ISRO to bring in the in-space. So now we have a policy that is in our hand. And the way that we wanted to work is to complement ISRO, right? Where we could like be working along together, sharing whatever we have. We had an opportunity to make India like to follow the principles of Make in India for the world, right? So that is exactly what we are targeting, being a first player in the space industry itself. So the difficulties that we had were being addressed because we were working out of a lab. That's within IIT Madras of NCC. There's a center called National Center of Combustion Research and Development. That's where we work out of from. And having access to such labs, the academic institution, the ecosystem, and all of these things have actually resolved this because for a startup to step out, with a huge infrastructure, and to do this would have been really impossible. So the help, or I could say the favors that we had in through the academic ecosystem, in the right time, the investor ecosystem accommodating, then the government also acknowledging the fact about creating in space. All of these things have put a line for the entire space industry to rise. So when we started, we found like 4 or 5 companies in aerospace. Now today we've seen around more than 20 companies in the space industry. So this is giving us a boost about how things are happening.
So from market perspective, how do you see aerospace industry, Moin?
Okay, so as I was trying to tell you, the other industries are also using space as a platform, right? So this is exactly like how an app store is working today. So all the phones will actually download anything that they require from an app store.
Mm-hmm.
Likewise, as I was trying to tell you about the pharmaceutical, there are companies who are thinking about doing microgravity research or protein crystallization that could happen in space. Mm-hmm. So the connection between pharmaceutical and space is also being done there. Likewise, there is a company that is interested in creating fake meteor showers. That is basically for an event. There would be something thrown inside the Earth's atmosphere which will actually glow up, creating an effect of fireworks. Right. So likewise, we also have companies that are trying to keep data in space, because storing data here in on the ground requires a lot of cooling infrastructure. All of these things would actually be quite free in the space, where their major expenditure is being covered out in space because cooling is free there.
Okay, fine.
So we see a multiple industries itself trying to utilize space, which is a good sign. And obviously, as I was trying to tell you, the conventional part is where the image sensing and the communication of satellites are down there, right? Mm-hmm. They have also been like shrinking. I mean to say, the big satellites have been trying to be broken down into the small satellites and are trying to be formed as constellations. Mm-hmm. So all of these things, right, put together, we can see a market that is currently trying to grow. So this is one part with only to the payloads. And then on the other hand, we are also seeing space travel trying to become a reality, where there are a lot of companies that are working towards this, mm-hmm. right? The space exploration has also started to happen, where people are trying to explore Mars and other planets as well. So we don't see this industry being like saturated in the next at least couple of decades. So it is still a technological advancement that is being made every year, and we're still growing.
Okay, that's good. So Moin, tell us about your team. So having someone to work in aerospace, especially doing all these R&D works, how have you formed your team? Tell us about it. And do you face any manpower or getting the right type of skill in India? Do you face any difficulties with that?
So to start with, the talent is abundant, right? So, but we just need to identify people who could put together the talent, mm-hmm. right, in the right way. Mm-hmm. The fundamental thing that we require or we look for in people is the passion, mm-hmm. to do something, to create a mark for themselves. Mm-hmm. Those are the individuals that we try to do. We have a saying that if you're good at something, that basically you will have a job at Agnikul.
Okay.
Right? Mm-hmm. We don't require people who would have done tons of degrees or 2 or 3 degrees. That's all the secondary requirement, right? Mm-hmm. The first one is to have your basic strengths, to logically think, have a rational, mm-hmm. and try to put up things together in such a way where it could be communicated. Mm-hmm. So the fundamental part of building a rocket is more about integration, mm-hmm. right? Mm-hmm. So it is not about you could be the world's best aerodynamics engineer or you could be the world's best propulsion engineer. But if you can't work with a person in the structures department, this would become very difficult.
Right.
So it is about accommodating for everyone's choices, mm-hmm. at the same time letting know what will be the impact of it. So the key word that we try to identify with people is a person capable of integrating, mm-hmm. with others so that the rocket also could be integrated.
Okay. So what is the current team size, Moin?
So we have a strength of around 60 people today. So we have a variety of people with us. Some of them have been postdocs. We also have people who are working on diploma level who work on the realization side. So it's a kind of a mixed team, right? Even age-wise, we have people who are from like 45 to even like 21.
Oh, okay.
So it is there's a lot of diversity. It's just it's from all over India. We also have people who've been to like countries like US and UK who have completed their masters or their bachelors and have been back to India. So it is we put across a team in such a way that it could all come into like diversification. At the same time, they all have to integrate.
Okay. Okay. So, Moin, my last question for you is about our rocket Agnibaan. So, the launch is expected to be in 2022. So, how has the company progressed with the rocket and what stage is it in currently?
So we've had multiple engine tests done, right? And on the other departments as well, we've had like the architecture frozen on the electronic side. Likewise, we've tested our tanks for both cryogenics as well as like for pressure and temperature too. That is progressing, and I think the first commercial flight, right? I mean to say, it would be in the later part of 2022.
Okay.
So that is when we are targeting for a first commercial flight. So which means we might have a developmental flight before.
Like, I'm very excited for the launch. I'll be like super duper excited to see a rocket that is completely made in India from a company like Agnikul going into space. That would be really exciting for us to watch. And from Circuit Digest team, we wish you all the best. And again, thank you so much for your time and taking part in this podcast.
Oh, thank you, Ashwin. Thanks a lot for having me. It was a wonderful opportunity for me also to tell what Agnikul is focusing on. Right? I mean, it was really good to talk about the team, about how we put together, as well as tell you about the technological advancements that we have made. Thank you for giving us this opportunity.